Hi, and welcome to your course on Introduction to Artificial Intelligence. In this course, we will talk about the main properties and technologies associated with AI. Now, let's speak about the definition of artificial intelligence. There are many different viewpoints on what artificial intelligence really is, but we will stick to this definition for the rest of the course. Development of methods and algorithms that allow computers to behave in an intelligent way. Okay, so we will speak about these technologies and methods later on. Now, when you look at the history of AI, you can see that there were many examples of the ancient interest in AI, really, and some of the examples may be the talking statues of Middle Ages, the myth of Colossus of Rhodes among the Greeks. So, Von Capellan's droid who played chess with Napoleon, or for example, Charles Babbage's analytical engine that was calculating algorithms. Now, all of these examples are somewhat related to the idea of mechanical intelligence in some ways. But even if you look at the fields such as psychology, you can see that Descartes, Hobbes, Leibniz, and Hume themselves refer to the human mind as some form of mechanism. So you can see that this idea of really artificial intelligence was something that has been interesting for people for a long time. Now, when we are speaking about artificial intelligence, we cannot leave out such a great man as Alan Turing. The AI was introduced to the scientific community in 1950 by the Englishman Alan Turing in his article Computational Machinery and Intelligence. Although research and design and capabilities of computers began some time before, it wasn't until Turing's article that the idea of intelligent machine attracted scientists' attention. So this is important breakpoint, turning point in the history of AI. The basic questions that Turing tried to answer affirmatively in his article was, can machines think? Turing's argument in favor of possibility of intelligence in machines initiated an intense debate that clearly marked the first stage of interaction between AI and psychology. And debates at that time focused on analysis, problems, and mentalistic terms. But the Turing's intention was not to use these terms as analogies, but to eliminate the distinction between natural intelligence and the artificial one. Okay. And two of the most important contributions to AI by the Alan Turing were, first, the design of first computer capable of playing chess, and more importantly than this, the establishment of symbolic nature of computing. Now, Turing's work was continued in the United States by John von Neumann during the 1950s. The central contribution was the idea that computers should be modeled on a human brain. So he used these analogies to anthropomorphize the language and conception of computing by talking about memory, sensors, and etc. of computers. And he also built a series of machines using what in early 50s was known about the human brain, and designed the first program that were storing the memory. This Dartmouth conference is really one of the most important events. At the time, an event occurs that would organize and give a great impetus to the development of AI. Congress and Dartmouth in 1956. In this Congress, where founding fathers of the discipline of AI met, the basic presuppositions of theoretical core or we should better say that the main concepts related to the core ideas and the core ideas of AI were formulated as follows. First, there was a recognition that thought can occur in machines outside of the brain. Then, that the thought can be understood in a formal and scientific way, and also that there was an assumption that the best way to understand it is through digital computers. From its origins, the AI was related to games like chess and Ladies, probably because table games are models of real situations, where you need to calculate, solve problems, make decisions, correct mistakes, remember, and etc. Many of the theoretical and methodological advances of AI were due to it. So when you simplify the problem to the idea of some game, it is much easier to train the program to do some intelligent function on it and to make decisions to win the game. For example, Samuel, one of the founding fathers of AI, designed in 1961 a program that played Ladies and was able to learn from its mistakes. That is, he was able to adapt his behavior in relation to the past events. The amazing thing about this program was that, coupled with its capacity for learning and memory, over time managed to defeat its creator. The same result was obtained by Bernstein through a program that played chess, both in 1977. The most famous of these type of interactions, however, between a machine and human occurred between Dreyfus, a bitter critic of AI, and the Mahak program, in which Dreyfus was defeated in the game of chess. And now here's the important transition. We have talked about the machines that were making some abstract calculations and doing some decision making on their own, without the physical world, without the interaction. And now here comes the example of the AI that would be connected to the real world. And this one is called Shaky. In 1962, McCarthy and Raphael began their work on the design and construction of a mobile robot they would call Shaky. The fundamental difference between this robot and the computer program used so far by the AI is that Shaky would have to face the challenges of interacting with the real world in terms of space, time, movement, and etc. In other words, the program would have to have some form of a knowledge of the world around it, and this challenge initiated a strong concern in AI. The study of epistemology and cognitive processes, discussion centered around problems of mental and internal representation of knowledge, perception, and meaning problems. Now, Raphael's basic idea was to gather in a single machine different machines with capacity to learn from experience, to model, to recognize visual patterns, and to manipulate symbols, etc. And hope that the whole was greater than some of its parts. The result of the experiment was not the result that Raphael had really hoped for, but it was an unprecedented achievement that made possible major advances in the future. The most important learning of this experience was the realization that the most difficult program to solve in AI was to build a machine capable of operating with high levels of uncertainty, as a human being does. It became clear that building a machine that did not effectively deal with uncertainty would be one of the two, either trivial because of the simplicity of the task, or impossible because of its complexity. Of course, AI must be observed in its evolution as a process that has allowed to extend the use of computers in order to replace the human beings in activities of intellectual work. But, however, there are questions that remain without a clear answer, such as what intelligence are we talking about, and can performance of intelligent work by some machine be truly intelligent function? Now, these are some of the philosophical questions about the AI, but you should think about those if you want to work on this field. The unfortunate thing about the Dartmouth conference is that the triumphalistic predictions were made for 10 years that were never met, resulting in almost complete abandonment of the investigation for 15 years. This was largely due to the fact that what we call natural intelligence was not a concept that has a clear definition. The various disciplines that try to explain it, as in the case of psychology, do so from various viewpoints, and several of them are contradictory to each other even. Considering the fact that AI as a discipline is interested in the mind and psychology and obtains results from such fields as, for example, neurology. One of the interesting as well as relevant questions about the AI, and I will leave you with that, is the approach that is proposed by Maurick Wilkes in the paper entitled Can Machines Think?, where he proposed as an argument the need to develop generalized learning programs that enable a computer to learn in any field.